this meeting. Okay. Right. Welcome back to PLAN258. Yeah. This is the agenda for today. So we'll discuss about linear programming, discuss last meeting. So part 5. And then the second topic about prioritization. Yeah. So I hope we can finish 2 at least. Okay. And if not, 3. Okay. Topic inside this big topic of prioritization. Okay. And yeah, if not finished today, we can continue next week. The server today is down. I'm not sure if you can open it from there. Yeah. This is the IP address, but I'm not sure it's working. Anyway, I apologize for the server not working. It's actually the whole lineup is down. Just my FLA2 server. Okay. Okay. Let's start with our material. We have first, this is what you see. Can you see my screen? Yeah. Okay. See that?
Yes, sir.
Okay, good. So this is what we have last thing. So I'm not sure if you can try. It's working. Okay, so we have the problem, a mixed land use dilemma. Last week we discussed about it, right? So say you want to design a new city district, some conflicting need. So this is the data. Okay, so you want to maximize the total annual tax revenue, and you have only 2 variables. Okay, because this is simplified version. Yeah, so either you build residential or you build commercial. Yeah, and these are the tax per hectare. Okay, but you have certain constraint. Okay, so you have land constraint because the total area available is limited, just 20 hectare. Okay, and then you have traffic constraint because based on the road capacity, have about 800 trips per hour. But if you build residential, you will add 20 trips per hectare. If you build commercial, you will add 100 trips per hectare. Okay. So, and then there is also the third constraint, which is policy. That means this is the law of the city that you must, as a developer, you need to have at least 5 hectares of residential. Okay, and we input this into mathematics. So that means you need to define the variables. Yeah? So let's define the variable x and y, which is the number of hectares of residential and commercial. Okay, and then our goal is to maximize the tax revenue, and we already know given yeah, residential will pay 10,000 per hectare of residential area, and then if it is commercial, okay, it will pay like 30,000 per hectare. Yeah. So then you want to maximize this tax revenue. Okay. So this is the second step, and the third step you define the 3 constraints above. Yeah. So once you put this, okay, this is just a recap from last week, right? So once you put this, you go to the lab. Okay, you can put this syntax. Yeah? So you want to maximize this and subject to this constraint. Okay, so tell me first, give me feedback. So is the website working or not? Or at least if the website not working, because you already opened last week, so it's supposed to work in your laptop if you use the same laptop.
It's working, sir.
Oh, it's working. Okay, good. If not working, we can shift to Excel. Okay, good. So once you have this, okay, so last time we discussed, you will get something like this, right? So this is the optimal value, okay, with four visible corner. These are the points in the corner, okay, and then we discuss more detail that the corner actually creating a kind of boundary or visible region, yeah. So this is a kind of polygon, okay, and usually the optimum value is in the corner, in the points, yeah, it's polygon, okay, and yeah, each line represent the constraint, okay, each line represent the constraint that we put, and this is the policy constraint is based on the law. Residential must be 5 larger than 5. The red constraint here represent the land constraint, right? And the third one is the traffic constraint. And we found out that the optimal value is here. For this problem, the optimal value is here. That means it happened when the land constraint meet with the traffic constraint, right? Okay, so these two constraints are binding. Okay, and then the other constraint that is not in the optimum part, in the optimum point. So the blue one here, this is non-binding. Yeah, we discussed last meeting about the dual, right? So I'm just recapping what we have discussed. So yeah, we can also have a different way to search. Okay, instead of searching from zero up to that, we can also put directly. Okay, and the last meeting we also discussed about shadow point or the value of limits. So once you have this optimal point, yeah, you need to develop 15 residential and 5 commercial. Yeah, these are the points. So then you're asking, uh, what if we put moral? Like, what if we buy Tantaro? Yeah, what change will give the biggest ROI, return of investment? So then you check which one is binding and which one is not binding. Okay, so binding mean the optimal point, okay, is actually passing the those constraints. Okay, so then if it is non-binding, then you will have what is called slug. That means you can relax that policy variables, yeah, in this case. Okay, and we also have what is called dual, yeah, shadow price in economic. Okay, so if you get one plus 1 unit more resources, yeah, how much profit you can get? Yeah, so which resources depends on the variable that you set. Okay, based on the dual, you will be able to ask how much saving. Yeah, if you can do something based on the resources that you have here, either the budget or the land traffic. Yeah, so this is the example. You have 3 constraints here, okay? And if you look at the calculator, it will show you the actual dual value, right? Okay, and it will tell you also it is binding or non-binding, correct? Okay, so and then if the value is actually positive, binding, you can invest. Yeah, if the value is zero, so do not invest. This is the interpretation of this. Yeah, and then from there you can also check. Yeah, uh, based on the sensitivity report. Okay, you're supposed to check whether what is the range. Yeah, you can increase or decrease. This is the current condition. You can still increase or decrease. Up to what point? Okay, so these are the allowable increase and allowable decrease. From there, you can make decision. Yeah, if there is an offer within that range, okay, whether you will buy it or you want to ignore it. Yeah, those are the main point of linear programming. Okay, okay, so let's. The path dilemma is not a problem, so I just want to show that you can also use different values. Okay, let's come back to the main part. Yeah, so today discuss about this risk and stability. Yeah, about sensitivity analysis. Is that okay? Mm, it's my okay. So in this section, okay, you will have you have to deal with what is called uncertainty. Yeah, this is the planner's greatest fear, isn't it? So we will answer what if, yeah, the market is volatile. How to measure uh, whether your plan is actually robust, yeah, safe, or whether your plan is actually risky, fragile. Yeah, when there is a change in the market price, for example. Okay, so remember, we just built a perfect plan, okay, assuming that the commercial rent will be like 30K, right, a while ago. And what if the recession actually hit next year and then the rent dropped to 20K or 15K? Yeah. So the question is, do we need to bulldoze the whole city and start over, or is this plan still valid? Huh? So remember, our model seems like static, yeah, but the reality is dynamic, isn't it? There is some changes. So this is called risk analysis. Yeah. So what is sensitivity analysis? Yeah. Sensitivity analysis answer the question. Yeah. How sensitive is my plan to error? Okay. So if a tiny change in the price force you to change your zoning, for example, completely, yeah, then you have fragile plan, isn't it? So, but if the price can double and the plan still the same, then you have robust plan. Yeah? So can you distinguish a robust plan and fragile plan? Yeah? So there's a change, the decision is still the same. That is robust. Yeah? But if just small change and then the decision need to change a lot, then you have fragile plan. Okay. So sensitivity analysis is talking about the range. Yeah? So question, is this plan risky or not? So then you want to know, okay, how much the price can drop before your plan fail. Yeah. Of course, if small drop and change your plan, then it is fragile. Yeah. Because a tiny market shift will break your plan. Yeah. But if the value is large number, so that means you have robust plan, yeah, safe to build. Okay, let's check your result. And you get this, right? Okay, so yeah, our mix a while ago is 15 residential and 5 commercial. That's the optimal plan, isn't it? Yeah. So, and based on this plan, we'll make most money with this 30K, yeah, per year. What if the price dropped to 25K or to 15K? Yeah. So at some point, it's not the worth of traffic headache, right? So we want to know exactly when. Yeah, when is the tipping point? Okay, so then you go back to that calculator and check this sensitivity part. Yeah, you just click the triangle there. Okay, and you will find adjustable cell, yeah, objective function like that. And then you see the column, yeah. You have a current coefficient, allowable increase, and allowable decrease, isn't it? Yeah. So yeah. So this is the current plan, okay, and you have also the sensitivity toward the constraint. Yeah, this is toward the objective. So yeah, this 30 current coefficient and 10 and 30. This is represent the uh, objective function, right? 10x plus 30y. Okay, so that means as long as the commercial pay uh, more than 10, yeah, we can just keep this plug, yeah, 15,5, yeah, 15 residential and 5 commercial. Yeah. But if this is the plan the drop, yeah, below 10, then it will change. Okay, so with that I put oh, why doesn't the plan change? Okay, so you might think if the profit drop 10%, yeah, shouldn't I bill 10% less, right? So the answer is no. Yeah, remember the answer is a corner. Remember, these are the corner. Okay, so you are wedges into that corner. Okay, so you stay in that corner until the economic change so drastically that is different corner will be the winner. Okay? So that's the meaning of sensitivity. Yeah. So be careful, even though this the name is linear programming. Yeah. In reality, the linear change in the input, yeah, doesn't mean that it will become linear change in the output. Yeah. In linear programming, the output is actually sticky. There is a discrete jump. Okay. So you must be careful not to think linearly. Okay. So these are the visible area. So think of optimization is like graffiti. Okay. So you have a table and then you tilt, yeah, table so that the marble will roll to the highest point, yeah, in the corner. Yeah. So if you change from, for example, 30K to 20K, that means you tilt the table slightly. Okay. So the sensitivity analysis actually measure how steep that tilt, yeah, need to be done before the marble suddenly roll to different corner. Do you understand the meaning of sensitivity analysis? Yeah, it's not just change little bit will suddenly move. Yeah, but depending on the tilting of that table. Yeah, this is just analogy. I hope we think using this you get better understanding. Yeah. So as planner, you look at the allowable decrease, yeah, and allowable increase. Yeah. So say, for example, if a tiny, say, case A, yeah, yeah, if it is tiny change, okay, so you will be terrified. Yeah, that means your plan is actually fragile. Yeah, that case you need insurance. Yeah, if it is wide range, robust, yeah, yeah, you can sleep well. Yeah, the market can crash, but you are still doing the right things. Okay, so at currently 30. So the lower limit, 29 point, not 29.5, that's very narrow. Okay, that's been dangerous. But the currently 30, but the lower is 10. That's quite far. Yeah. So then you're okay. Okay. So let's do a quick test for you. This is another scenario. Okay. Just decide, yeah, go or not go decision. My question is this plan robust or not? Yeah, the plan is on the uh, right side here. So we are building a solar farm. Okay, so just one variable x. Okay, the LP, the linear programming calculator, say that you are safe down to 98. Yeah, see, the lower limit is 98. So say the experts say the price will drop to 95. The question is your plan robust enough or not? Yes or no? Any idea? So, so current price is this one. So what do you think? How much is your safety buffer? This one, two, isn't it? Right? So your safety buffer is actually drop two. Okay? And how much is the prediction? Yes, Joyce.
I think, sir, do not proceed as planned, sir.
Yes. So
Uh,
this allowable decrease is only two.
yeah, because
But
100 minus 5, it will be 95. Then the
correct.
lower limit is only 98.
Yes. So the 95 is less than 98. So it's a breakpoint trigger, right? So it's not allowed. It's not robust enough. Yeah, your plan. Okay, very good. Okay. So let's to wrap up this section. Okay. So remember, yeah, optimization is not just about the best answer, isn't it? But it is also about the safest answer. Yeah. So if you use sensitivity result, okay, to defend your proposal against the skeptic, yeah, who said, "What if the price changes?" Yeah. So you can look at them and say in the eyes and say, I check, okay, we are safe down to say $10. So you know what you are doing. Okay. Uh, so far, can you follow? Do you understand, or is there any question, discussion? Good, everything good. Okay, so then let's continue with the next part. Yeah. So in this next part, yeah, this section, so we deal with the problems, it's a complexity where we cannot graph. Okay, so we cannot graph because the number of variables is more than two. Yeah, you can only graph that if you have two variables. Okay, there is also possibility that the uh, values are integer, okay, or rounding issue. Yeah, so this means we transition from the toy problem, just two variables, into the real problems. Yeah, with many variables. Okay, so I hope it will help you to understand. Okay, so uh, let's come back to the real city. Okay, last part, last sections, we only have two choices, right? Residential and commercial. Yeah. But in reality, you have more than that, isn't it? You have, say, you can have high density housing, yeah, low density housing, retail, park, road, and so on. So in that case, you will have many variables, correct? Hmm? So yeah, in real life, you have thousands, yeah, of choices. Yeah. So you can also have industrial part in here. Yeah. All all at once, isn't it? So what is the good news here? The good news is because the mathematics still the same, the logic still identical, okay? Adding more variable, okay? All you need to do is just adding uh, more term, yeah, in the equation. Yeah. So the same ingredient, yeah. You still have the goal, you still have the variables, and you still have the constraint limit. Yeah. So this three does not change any optimization. Yeah. So it's just change the length of the equation. Yeah. The number of constraint will become much bigger. Okay. So now here is the scary part. Yeah. So once we go above uh, two, or three variables, okay, then we cannot draw, right, the visible region anymore. Yeah, we will exist in what is called hyperspace. Yeah, say four-dimensional hyperspace and n-dimensional hyperspace. Yeah, so uh, our brain cannot see. Yeah, so we are flying blind. Yeah, we cannot. We can no longer check the graph. Yeah, what to do. Yeah, we trust the numerical output of the calculator. So that is the last part there in the calculator, the tabel, in the tabel. So you just need to stop looking at the shape of the graph. Okay. Now you need to go into the numbers. Okay. So you just trust the numerical output of the calculator. Yeah. So we may lose the visual intuition. Yeah. That's why we need to practice reading the tables. Yeah. As soon as the table, uh, uh, we have all the variables, then we understand the meaning of the table. Okay. That table, okay, come from what is called simplex method. Yeah. Remember, originally it was built uh, during World War II. Yeah. So the question is, how does the computer solve, say, 1,000 variables problem, yeah, without a map? Yeah. So this is the algorithm, yeah, called simplex. Okay. So imagine you are going into the mountain top, okay, but in the fog. Yeah. You cannot see the peak, but you can still feel it, yeah, if the step go up or not. Yeah. So you take that step, okay, blindly touching the surrounding of your situation. Okay, then if you keep stepping up, yeah, until every direction is down, yeah, then you know you are going up. Yeah, so that exactly what the mathematics inside the computer do. Yeah, so this is to simplify the heuristic inside the simplex method. Yeah. Yeah. I hope this is not a mystery black box anymore. Yeah. So let's try, okay, with transport problem. Okay. So let's try with three variables. Okay. To simplify again. So say you you are buying a fleet. Yeah. So either bus, rail car, or bike lane. Okay. So we want to move people, right? So what's that? We want to maximize the capacity. Yeah, remember capacity is not necessarily money, but any variable that you want to do as your objective. Yeah? So then you have a budget limit. Yeah. So and you also have the space limit, say the depot slot and so on. Okay. These are the constraint and the objective. Okay. So can you put this into the calculator? Yeah. Is it working? Uh, Please notice the difference in the coefficient. Yeah. This one. This is 10. This is 200. Very big difference. Okay. Yeah. The rail is expensive. This is B is bus. R is rail. And K is the bike. Hmm. The rail is expensive but high capacity. Yeah. This is the budget is also the different. You try? Okay. Okay, but I cannot see you. Oh, you don't need to put million, yeah? Yeah, M is million, but you don't need to put the M. Otherwise, the calculator will think about M as variable. Okay. So let's start to see the several problems, yeah, that we have. Okay. So we run the model, okay, and the computer will say, example, R is 3.6 rail car. Well, we cannot buy 3.6, isn't it? 0.6 train is not exist. Yeah. So then this is actually integer. Okay. So while our problem is standard linear programming, which assume everything is like water, yeah, divisible. Yeah. But the train is like a brick, yeah, solid. So then you start to feel, oh, the model is broken. Yeah. This is not a bug. Okay. So real life sometimes discrete. So what should we do? Yeah. So there is a technique called uh, linear programming relaxation. Yeah. So this is the boundary that you have. Okay. Usually we'll get a corner, right? As our possible, okay, feasible. These are the feasible region and these are the possible optimum value. Okay. But if you need to get integer, then you find the integer solution. Yeah. These blue points are the possible solution. Yeah. Discrete. Okay. So in that case, you need to round up or down. Okay. So you get 3.6, then you probably want to round up to 4. Yeah? But very careful. Yeah. If if you round up, you spend money you don't have. Yeah. So in that case, you may break the budget constraint. Okay. So in that case, you better round down to 3. Yeah, from 3.6 round down, you get the floor. So this is safe. Yeah. Then you will look at the leftover money, the slot, okay, and see if we can buy some cheaper buses or buy plane to fill that gap. Yeah. So this is not the true uh, integer programming. Yeah. This is just heuristic, yeah, so that you can do based on the rule of thumb. Yeah. So this is the rule of thumb. Yeah. So just round down. Okay. Uh, but be careful also if you are building, say, 1003, yeah, and then rounding 1000.4 down to 1000 is fine, right? So nobody cares about 0.43s. Yeah. But if you are building hospital and the answer is 1.4, and then you round down to 1, then there is a massive loss of service, isn't it? So in that case, round up to 2 uh, may be good, but it might bankrupt you, okay, because the budget is bigger. So for a small number, yeah, uh, in that case, you must calculate both scenario A, which is hospital, one hospital, or scenario B, two hospital. Then you do separately, yeah, and you check manually both option. Okay, so and be careful also. Yeah, sometimes it happens something like this. Yeah, so these are the possible LP corner, right? Okay, and if you discretize, okay, you will get this is the actual point that's supposed to be the optimum. Okay, but if you round down from here, say from this circle, it will become invisible. Yeah. Similarly, if you round up a little bit in here, yeah, then it will become invisible. Yeah. So uh, if two dimension you can see, but in reality, if you have many variable, you cannot see. Yeah. So this is also big problem. Yeah. So to summarize, yeah, do not be afraid of high dimensional problems, okay, because the computer will handle them. Yeah, and don't panic when you see the decimals. Yeah, just use your common sense to round down to stay safe. Yeah? But be careful with the big or expensive items. Okay. So next, I want you to uh, exercise. Yeah, so that you can have. So, do you want to exercise in a group or individual? So, I hope this capstone workshop will bring all the concept together. Yeah. So this is like the exam without pressure. Okay, let's create a room then. Huh? Yeah, okay. Group. So how many groups do you want? How to make- Wait, I will stop sharing. Breakout room. Nah, there. How many you want to have breakout rooms? Oh, you want the existing group. How many groups do we have? Three or four? So I will separate you into groups. So you go to your own groups. I think you have three or four, right? Anyway, I will create four rooms, four breakup rooms. Okay, so you can go there. How many minutes do you want to discuss the uh, capstones workshop problem? You have the slide, right? So you can see. So the challenge is a disaster relief logistic. Okay, So you are the emergency response coordinator. Uh, so you go to that group, and then your goal is to maximize the survival, yeah, shelter. So call this. You have two options, whether you put it in the tent or you put in the pot. Okay, and then you have three constraints: you have budget, land, and policy constraint. So you see the slide. So you can go up. Oh, let's make agreement. How many minutes you want to talk in the group, and then come
Thir-
back. Hmm?
30? 30, sir.
Oh, a lot.
So what do
Okay,
you think,
so
sir? How
how
many
about
minutes?
20 minutes? 20 minutes.
20. Okay, sir.
Okay. So now is 6:42. So 7:02. Is that okay? Come back here 7:02. Yeah. Okay. So you go to your own breakout room. Okay. And I will post the recording.
The rail
Bike lane.
is
Okay. What happened?
in the bike lane. We didn't reach to the 3.6 number of rail
No,
cars
no, no. It's
using the
just an
it's just an
example.
example, right? Because when we use the linear programming lab,
How
virtual
much you
lab,
get?
to zero rail cars.
Zero red cars.
Yes.
Okay. Just an example only. So to get the point that there is possibility of
The
you know,
rounding. Okay.
rounding off.
Okay. Thank you, Prof. Just
Yeah.
clarifying.
Okay. So I will break up all the rows. Okay.
Prof, while waiting for the others,
Mhm.
so does our government or does the Philippine government use this right now to analyze the situation of the traffic?
You tell me.
I'm curious. Okay.
So sometimes we need to educate, right? I understand some of you are doubting why we need to learn something like this. But the question is, once you don't, when you don't know, then you will never use, correct? But once you know, probably you will use. Okay. Uh, so that's the main point there. Okay, so anyone want to share screen for each group? What did you get?
Sir, we will share screen.
Also, hundred 1,000. That one is not 500. Good. Larger than 5x plus 20. Yeah, okay. So that's what you get. How much? 500,
We're
100.
getting 500, sir. For the tent, we're getting 100. Then the Y, which is the pods, is 0.
Okay. What's the meaning of that 100 and 0?
This is the survivor. X is 100, which is the survivor. For the tent, I mean that the tent.
Okay, so 500 is survivor and then
Yes,
100 is
the tent, sir.
the 10. Okay.
Yes, sir. So
So
5
you
times
got it.
100 is 500 survivors.
Okay, good. Okay. So And then what will be the shadow price? Maybe the next group.
Okay,
Uh,
sir. Okay,
okay,
sir.
thank you, thank you. Next group, can you explain the shadow price? Yes. Uh, Group two.
Sir, we are the group 2.
Okay.
Yes, sir.
What's the meaning of this?
I mean, sir, I already presented
You
the
already
first slide.
group two.
Yeah.
Okay, so then group one.
Okay, sir.
Thank you. Go ahead with the representative of group one.
Okay, sir. For the constraints or the shadow price,
Mhm.
um, for the constraint number one, which pertains to the cost, so the budget has a shadow price of 0.025,
Mhm.
means it means that um, that increasing the value of the 20,000, the total cost by one unit improves this constraint by 0.025.
Mhm.
And then for the second constraint, which pertains to the lot area, so this the shadow price showed a value of 0, which means that this is not a binding constraint.
Okay.
So increasing or decreasing this value won't affect the result of the optimal solution.
Yes. Very good.
And then same with the last constraint, which pertains to the number of tents, the minimum number of tents, which is
Mhm.
10.
Mhm.
So same with the second constraint. This is also not a binding constraint,
Okay.
and it won't affect the result if it is changed in a higher value.
Okay. Very good. Okay. So group three. How about the sensitivity analysis? Will be the representative of group three. Hmm.
Hello, sir. I will be presenting my screen.
You can share screen if you want.
Okay, sir. So here's our work. We replicated
Okay.
what was done. And then for the sensitivity, uh, the results show that we can have an allowable increase in the budget. Wait, that's constraint one. So the budget by 4,000
Okay.
and an allowable decrease of 18,000 for the budget. So that's the range of 2,000 to 24,000 uh units, or is that dollars? So yes.
Okay.
Yes, sir. So
So,
for land,
can you see the objective function there?
objective function, sir.
Mhm. No, no, I mean the sensitivity of objective function.
Okay.
Yeah,
Ah,
that one.
here,
So currently you have five.
5.
Okay. So allowable increase is unlimited, but allowable decrease is one. So only up to
That's
four.
410.
Yeah, 410. Yeah.
Yes.
So you cannot if uh, there's an offer to put only 310, then it's not allowed. because it will change the decision.
Mm.
Okay. But for the pot, the Y, currently you have 20, right? But
Yes,
yeah, so you can
allowable increase up to
up to
25.
25. Yeah. Okay. But minimum is unlimited, so you can put zero.
Okay.
Okay. Okay, so the last but not least group four. So can you explain the um, constraint sensitivity? And yes, Paul Alan.
For the constraint sensitivity,
Can you
before the
share
first
your screen so that the others will can also see?
okay.
Okay.
Actually, you already received the results, so let me
Yeah.
just explain here. Based on our group,
Mm-hmm.
and for the first constraint, this is the budget constraint
Mm-hmm.
since we have only 20,000 for this. So
Mm-hmm.
increasing that by 1 unit will increase the number of survivors by 0.025. While the second constraints, the land, as well as the third constraint, the minimum number of tents are both zero.
Mm.
Therefore, the land and the minimum number of tents are non-binding constraints or
Correct.
slacks. We should not consider them. While the only binding constraints for the first condition was the budget.
Mm-hmm.
Therefore, in order to further increase the number of rescued survivors, the constraint that we should consider was the budget. We need more budget for this. Yeah.
Right. So you need to read the allowable increase or decrease and the range. Yeah. So from the current value, okay, uh, plus and minus with that allowable increase and decrease, you will get the range. Okay. Okay. So far, very good. Okay. Is there any question about this? No question. Is it clear already? Okay. So I will share my screen then. Well, can you see my screen? So this is the table that is probably useful for you. Okay. This is if you want to see what kind of problem I can deal with. Yeah. So you have some kind of resources. Okay. And then you have the resource usage per unit of activities. Then you have n activities. Then these are the data that you need to have as your constraint. This is the left-hand side of your constraint, and this is the right-hand side of your constraint. Yeah? And then at the bottom here, for each activity, okay, this is your coefficient of your objective function. So this is to summarize, okay, any type of linear programming, you will have this kind of data. Okay. So, and in general, okay, this is because you have this kind of table data, okay, then that table data will be uh, put into matrix, yeah, matrix A. Yeah. And X is the decision variable. Okay. So you have X, Y, Z, and so on, or X1, X2, X3, X4. And then B here is the right hand side, yeah, the amount of resource available. Okay, so this is the general LP, yeah, linear programming. So then you will ask, how can it become equal? Yeah, but our constraint is actually unequal, right? So this is actually inequality, okay, but you need to make from inequality, you need to make it into equality. Yeah? So I don't want to go to detail, yeah, on how to solve that kind of problem, okay, because that will be too much mathematics for you. Okay, but if you are interested, you can ask, or I can point to you for the books. Yeah. So these are the guide for universal solution. Yeah? So question is, what is the objective that you are trying to optimize? Okay? And what kind of decision you can control? That is the decision variable that you want. Okay. And then what items dictate the constraint? Okay. So then from there you find the coefficient, yeah, of the objective function and get what decision provide us with the optimal value, yeah, based on that decision, objective function and the constraint. Okay? And then you can start to do also what is called sensitivity analysis. Yeah? Okay. Now, if you can solve this, yeah, then you can get the actual solution. So the whole course of this plan 258 is about optimization. Okay. Then you start. This is the beginning. Okay. Later on, you will get different cases, different method, which is all about optimization. Yeah. Then you will have three things that you need to remember. Yeah. Number one, you need to have the goal. Okay. Yeah. Ah, the variables, the decision variables. Yeah. Second, you have the goal. The third one is the limit or the constraint. Okay. So to solve, you need to transform that into mathematical language. Yeah. Then you can put into a solver, calculator, or spreadsheet. Yeah. So, any question? So far, so good. Okay. So now we will have this practice of what is called transportation distribution problem. Okay. This is logistic. Yeah. So say you have a number of suppliers and the number of outlets, yeah, to represent the demand and supply, and then the unit cost of the goods is also known. Okay, now this problem is called transportation problem. Okay, so you need to find the number of goods shipment from each pair of supplier and the outlet, yeah, so that the total cost for the whole system is minimized. Okay, so here is the practice problem, and then I will guide you using Excel at this point, not using calculator, okay, so that you will know both sides, yeah. You have the calculator you can also use, but try to use Excel in this case, yeah. So let's read the problem, yeah. A computer company have two warehouse and two retail shop, yeah. So warehouse A, warehouse B, retail shop Y and Z. Okay, so warehouse A have 250, yeah, okay, computers, and then warehouse B will have 400, yeah, okay, and then the retail shop Y, this one need 300, okay, and then Z need 200. So this is the demand and the supply is given. Yeah, the transport cost is also given. Yeah, very typical. Okay. Now, how the transport company will transport the computers, yeah, to minimize the cost. Okay. Number one, understand the problem. Do you understand the problem? What will be the objective here? What will be the constraint? What will be the decision variables? Anyone? Any idea? Yes, Paul. Yes, Paul. Yeah.
Hello, sir. I think the decision variable is to lessen the cost. We need to meet the demands of retail shop Y and retail shop Z while minimizing the transport cost of each computer for their demand.
So how many variables do you have in here?
Sorry, sir, come again.
How many variables do you have?
Mm, four, well, no way.
Four. Okay, which one is the variable?
The variables would be the transportation for from warehouse A to retail shop Y. It would be AY.
Okay. Okay, very good. So
For
let's
A to Z
let's
is
let's call this x. Yeah, this is the variable a
S.
to y. Yeah. So this one is the first variable, right? And then
Mm,
the second one is x from a to z. Is
A
that
to Z.
correct? Yes, very good. Yeah. And then you have another
The third
variable
and
here,
fourth
right?
variable would be
From b
B to Y.
to y. Yeah. And then the last one is x from b, okay, to z. Yeah, this is the crucial part, isn't it? So number one, you need to decide the variables. Yeah. Okay. What is the meaning of x, a, y? That's the number of computer. Is that correct? That you will ship from warehouse A to retail shop Y. Yeah. What is the meaning of uh, XBZ here? That means the number of computers, yeah, that you will ship from warehouse B to retail shop Z. Clear, yeah? Yeah. So once you have the variables, okay, the second step is to understand the objective function. Okay, who knows what is the objective function here? Of course, the objective function must include the all these decision variable, yeah, these four variable, isn't it? Okay, can you do that? Yes, Lester.
The objective function would be since the goal of the company is to minimize the transport of computers to each retail shop. So
Okay,
it would be minimize the
minimize.
function of z, which is equal to 18 xay
Very good.
means the cost for transporting the computers from warehouse A to retail shop Y,
Mhm.
and then plus
Plus.
15xaz
Very good.
plus 12xby
Mhm.
and then plus 14xbz.
Excellent. Yes. Okay. So you have the variables. Now you have the objective function. Next, what would be the constraint? Okay, you have, yes, Diane.
Well, one constraint would be the number of computers in warehouse A, which is 250. So it
Very
must
good.
be equal to it must be the total of XA1 and XAZ must be less than or equal to 250.
Very good. Okay. Next constraint. Who can identify the next constraint? That is the demands constraint of warehouse A. Yes, Roger, Regilio. Yeah. Go ahead.
Sir, we need to accommodate the demand of each retail shop.
Mm-hmm.
So to represent that would be XAY plus XBY is equal to 300. And
Equal or wait.
Sorry.
Equal or less than or larger than. Hmm. What do you think? Need 300. Yes, Andro?
Hello, sir. So if the retail shop needs 300 computers, so and we want to minimize the transport cost, so
Mhm.
it shouldn't be more than 300, but it shouldn't be less than 300. So I think it should
Equal.
be equal to 300.
Okay.
That's my interpretation.
Okay. How about the warehouse? Okay. So yeah, first you need to identify variables. Yeah, and then you get this. This is in that table, right? Similar to a table a while ago. Okay, and then you identify the constraint. Yeah, that the total demand is equal. That's correct. Yeah, but the total supply must be less than, right? So yeah, this is the non-negative constraint, of course. So there are three types of constraint: yeah, supply, demand, and non-negative constraint. Okay, now knowing this, you know the objective function and the constraint. Okay, how are we going to use Excel to solve this? Yes, you know how to do it using calculator, right? Easy, you just type, okay? And then semicolon, semicolon, yeah, that's okay. My question is, how are you going to use Excel to solve this? Mhm. Right, okay. So in Excel, you have what is called solver, right? Okay. So this is the objective function a while ago, okay? And you want to minimize, okay? Then uh, these are the whole LP formulation. Yeah, we just summarize all of this. Yeah, if you want to use Excel, this alternative solution I will discuss later. Yeah. So what you will do is, okay, you put the variables. Yeah, you put the variables like this. Can you? You type the name of the variable. Okay, and then you put 000 or whatever number first. The one in yellow is the one that you input. Yeah. And these are the costs, right? So you input also this one. Can you? Uh, Now, this is the key, yeah, to play in Excel, yeah. So you need to identify all the constraints, this one, right? One by one, you put it here. Huh? You put it here. All these constraints, you put it here. You type like this. And then this is the crucial part, yeah. This cell C12 must be XAY plus XAZ. So you need to put this value. Okay, let's do it with demonstration. Let's do it together. Is that okay? I will open my Excel. Yeah, I will remove. So this is an Excel sheet, empty, right? So what you want to do? I want to do this one. Okay, so I need to have the variable. So what is the variable? X, A, Y, X, A, Z. Okay, let's make it same. Can you see my Excel? From X underscore, yeah? Z X underscore PY, right? And then X underscore PZ. Okay, so this is the variable that I'm on. Okay, so I will put this yellow. Initially, I will put any, yeah? So I can put 0 or 111. Let's copy one. Okay, I will put 1. Or let me put it so that you can see, yeah? 1, 2, 3, 4, yeah? So and then we have the constraint, yeah? So this is the variable. Now let's do it the constraint. Okay. So what's the constraint? You need to have this one, yeah. Number 1, yeah. So this x plus xaz, isn't it? xaz. Yeah. So okay, if you want to have this is the left hand side, LHS, and then this is the inequality, and then this is the right hand side. Right. So, okay. So what you will do so that I will not remember all of this in dollar sign. So what I will do is here. This is the key. Yeah? So you go to formula. Yeah, first you highlight this. Can you see? You highlight this variables. Okay. Then you go to formula. Okay. And then create from selection. There. And then we'll ask you left column and then click OK. If you do that, you will have this. Can you see this? This one is the X, A, Y. Go here, X, A, Z. So it will give name, yeah, of this if this cell, yeah. This cell will have name. Are you okay with this or not? So giving the name of variables in Excel, you know. So then what you will do, you have equal, what you will do, equal a x a y, this one. See, you will see now in variable, right? And then plus x a z there. So of course 1 plus 2 is 3. Yeah. What is the next constraint? X b y plus x b z. And then okay, let me this x score ay plus what is this? Supposed to be by, isn't it? By. And then the last one is x underscore az plus x underscore pc. Is that correct? Yeah, based on this formulation. Okay, so the inequality you just copy. Yeah, so less than equal, right? Less than equal. This is just for ourselves to remember. Okay, and then what you will do, you will do exactly that. Yeah, so x b y, this one, right? Plus what? X b z. This is to help you. And then this one is x a y plus x b y. Is that correct? And then the last one is x a z plus b z. Okay, so you're supposed to get exactly the same value if you use the same value as mine. And then what is this? The right hand side is 250, you just copy, yeah. And then 400, right? 300 and 200, yeah. This is the one that we just type, yeah. So the one that you just type, I will put it yellow because you type. Ah, okay. So you need to make like this. Okay, this four constraint below, yeah, this is just boundary condition, right? So you don't need to type, yeah. So these are the four constraints that you need to type. So the most difficult part is actually to type this one. Done? Finish? Okay, if not finished, I will wait for you. Oh, you're done. Okay, very good. Then what you will do, you go to File or Option, right? Add-ins. Okay, click OK. Where is the File Options, Add-ins? Here, go. And then you need to put this one, Solver Add-ins. Click, yeah, and then click OK. Yeah. So once you have that, what you will do, you will see in data, uh, you will have solver. Open that. Oh, we did not make the objective function yet. Okay, so let's do the objective function. The z. Okay, so what is the objective function? Oh, okay, I will type here. This is the coefficient. Okay, so this one is 18, right? 15, is that correct? And then 12, and then 14. Yeah, this is the objective function coefficient. Again, because this is I type, so I put it yellow so that you know this is the one that I type. Yeah. So the z, the objective function is what? Equal to some product. Yeah. Some product of this one, okay, comma coefficient, right? There. So this is the computed. Okay, so you have the objective function, you have the constraint, okay, you have the variables. Complete. All you need to do is now to run the solver, yeah. So you go to data, you go to solver. What is the objective function? So this z, yeah. Okay, if you don't like to that, I will put like this, or I will just put, I will go here and then I will type here z. There. Yeah. So this is z. Okay. So solver, I will have z in here. What do you want? Maximize or minimize? Minimize, right? So what variable you will change? This one. This is the variable that you will change, right? And then what are the constraints? The constraint is this one. Oh, one by one, yeah. So this is, should be less than this one. The second constraint is this one, less than this one. And then you add again the third constraint is this one. Oh, this is equal, yeah. This is equal. So equal to what? Equal to 300, yeah. And then add again the last constraint here. This is equal to 200, yeah. Then click OK. So if you check this one, make unconstant variable non-negative, that means all the boundary, yeah, a x, a y, a z, yeah, by, and bz are all non-negative, yeah. Then what you will do, solve, yeah. There you get the solution, yeah. If you want to do sensitivity analysis and the limits is already here, yeah. So you just add. So and then click OK. Now you put the three of them. And click OK. There. You get the answer report. You get the sensitivity report. You get the limit report. Exactly the same, yeah, as in the calculator. Okay. So if you don't want those reports, you just get the data. Yeah, I will rename this as data. Rename. Okay. But what happened? Why this one? Oh, I will get the Z6500. Is that correct? Yes. And this is the result, yeah? This is the final result. The result is automatic here. Yeah. You can also see the report here. Yeah. The result. A while ago was 1, 2, 3, 4, right? So it will change. Okay, can you do it? Is there any question? So which one is easier? Using Excel or using the calculator? It's the same, right? So you still need to type, isn't it? Yeah. Calculator is game changer. Yes, true. Yeah. So, but the calculator have limit. Yeah, cannot calculate integer. For example, in Excel you have uh, you can change the, for example, this one. Yeah, you change into integer. That integer can make it binary. You can also change into all difference. Yeah, to find unique value. So this is much more complicated. Yeah. The same thing, you are using non-linear. This is basically like the Newton method. Okay, there is also simplex. So calculator is only using simplex. Okay, there is also this one is evolutionary. That means you are using genetic algorithm. Yeah, so Excel is much more complex than what we think. Okay, so the calculator is only using simplex. Okay, but the result is the same. Yes. So calculator probably only can get up to 100 variables. In here you have 250, I think. Can have 250 variables. So the number of variables matter. Yeah. For a small problem, no problem. If you have a very big problem, more than 250, you cannot even use Excel. Yeah, you need to use a special tool for optimization. Okay. for real production with million of variables. So then, yes, you need to have a very expensive software to solve optimization. Yeah. You probably think, oh, is it really useful? Well, if you understand the meaning of optimization, yeah, just a small shift, okay, if you change, yeah, the benefit, yeah, or the cost is massive, yeah, can be million of dollar, can be billion of dollar, okay, so it's not small amount. So in that case, really worth to have this kind of optimization, yeah. So you get the idea. Is this too fast? You can follow, you can make it. Okay, good. So let me go back to the slide then, yeah. So a while ago, mm, we are using 4 variables, isn't it? We are using 4 variables. So an alternative way, alternative solution is to use not just 4 but 2. Yeah. Why? Because of the equality. Yeah. So if you notice the constant of total demand, yeah, there is equality, right? This one. Because of the equality here, then you can improve, yeah, because you already know this is equal, then you can put it in the right hand side, yeah. So B X B Y, right? This one equal to 300 minus, right? X A Y. Yeah. Similarly, X B Z, yeah, okay, is equal to 200 minus X A Z, isn't it? Yeah, because you have equality. Yeah. Once you have that, so you just put it inside. So now you will have, okay, similar, but now you only have 2 variables. Yeah? Okay, XAY and XAZ. Yeah. So it's simplified, of course. Well, okay, it's simplified. Everything is the same, yeah, except now you use this one. Yeah. Uh, but now the objective function change, yeah, and then the constant also change. Okay. So this is the first constraint, yeah, based on this table, right? Okay. And this is the second constraint, yeah. So now you have now your non-negative constraint also changed, yeah, because a while ago it's just positive, yeah? But because you replace, so you need to change that, yeah. Now no longer just larger than 0. Now you need to put this on the right hand side, become less than 300, and this one less than 200. Yeah. So yeah, you need to do some certain algebra, yeah, to do identify the two the constraint, yeah, of the 2 variables. Okay. After that, yeah, objective function also change. Yeah. So uh, because the variable change, so this one you input, yeah, a while ago, so become 300 minus, and then this is 200 minus. Then you simplify. Oh, now you have a intercept here. Yeah? Okay, so if you multiply this 12 times 300 plus 14 times 200, so you will get this value. Huh? Okay, so once you minimize, so your constraint suddenly become simple, but now you have intercept. Yeah. So now we combine all of this. This is the LP for 2 variables. Yeah. Okay, so this is the one that you will put into Excel. You want to practice? Huh? So can you, I will stop sharing this. Okay, and you go to Excel. Where is my Excel? Okay, so this is data one. Okay, so then you create a new sheet, and let's name it data two. Yeah? And then you copy the whole screen so that you will see. Let me put it there. Okay. Did I share my screen? Yeah. So you copy this from the screenshot, okay, so that you can identify. Now you have two variables, no? So you have x, let's make it xay. At this time, I don't put the underscore so that it's different. And then this is xaz, xaz. Okay, so I don't know the value, so I just put any value, 1 and 2, right? Okay, because this is the one that I type, so I put it below. And then you have the coefficient here, yeah? So the coefficient, yeah, this is the coefficient 6 and 1. This is 6 and 1, is that correct? Again, this is because you are the one 5. Oh, there is another coefficient here. 7 to 800. Okay, so this is another coefficient. And then you have the constraint now. Okay, so x a y plus x a z. The second one is x a y plus x a z. Oh, the same constraint, but different sign, different right hand side. Yeah. So let's make it like this. This is the left hand side. This is the inequality, and this is the right hand side. Okay. And I still have another constant here, which is x a y itself. And then I have also x a z. Okay. So now let's give a name then. Yeah, let's give a name to the variable. So then you go to the formula, create from selection, right? Okay, and then click OK. There. Then check. Oh, you will see the variable's name in the name box. Yeah. The same thing here. Okay. Sorry, this one. Oh, what is missing? Okay, this one I need to put the left hand side is this one plus, yeah, this one. Okay, this is correct. I copy this because exactly the same constraint, right? And this one is just XAY. And this one is XAZ. Just copy, yeah. Equal of the above, yeah. Okay, so you will have this as formula. So I will give different colors so that you know this is formula. Huh? So the difference is in the equality. So this one is less than, this one is larger than. Oh, be careful. This is different. This is also less than. This one also less than. Yeah. So the boundary I don't put because anyway Excel already automatically set. Yeah. So what is the right hand side? This is 250. Is that correct? 50. This one is 100. This one is 300. This one is 200. Okay. So because this is the one that I type, so I just put yellow. Ah, to make me remember that this is the one that I type. Okay. Uh, Last but not least is the Z. Yeah. So what is the Z? Oh, the Z is, I'll just put equal. Yeah. You can put some product if you want. Some product again. Some product of this one and this one. Oh, be careful. Not all. Okay. And then what you will do, you close and then you plus, yeah. Plus what? Plus the intercept, yeah. This one. Yeah. Can you see? Okay, so if you are correct, you're supposed to get similar result. Okay, so we are ready to put into solver. Yeah, so you need to prepare. Yeah, Excel, you need to prepare all this. Practically, this is the matrix. Yeah? This is the left hand side is the A, matrix A. This is the vector B, and then the Z. Yeah? So exactly similar to the uh, formulation of LP a while ago, yeah, the general formulation of LP. And what you will do, yeah, go to data, you do the solver. Now you need to get this one, the Z. Okay, what minimize or maximize? Minimize, yeah. By changing file, these two, right? Okay, and then subject to constraint. Oh, again, you need to do it one by one. Why one by one? Because they are not the same. You know? If the equality is the same, you can put all together. This one less than, correct, yeah? The right hand side is 250, you add. And then the second constraint, oh, be careful, this is larger than. Oh, okay, larger than the second constraint, you add. And then the third constraint is this one less than the 300. And then add the last constraint smaller than this one. Click OK. Oh, I have the four constraint. What you will do? Oh, you just solve it. Okay. You want to get the answer, sensitivity, and limits, or you just keep solver? Yeah, it's up to you. Okay, let's do this one. So you do that. Okay. And click OK. There, you get the result. Yeah, 0 and 100. Okay. And this is the answer is in the yeah, 0 and 100 here. Same. And the final value is this one. And this is the sensitivity report, and this is the limit report. Yeah. Same. And this is data too. Is it very clear or not clear? Is there any question? There. What's the difference? A while ago was 722,800 increased by 100, so you times 1, so you get 722,900. Yeah, the Z is not the same. Okay, replay of this part. What do you mean video replay of this part, Paul? I'm not sure what your question is. Our conversation is recorded. I will put in YouTube, and then the link is already in. The link will be in Moodle. Okay, so if you go to the Moodle in level 2, right? Okay, and then you go down there. 2026 lecture. So all the lecture will be there. Okay, including the Zoom AI. Yeah, from the first meeting. Yeah, so you can check there. Yeah, later I will add here. This is the previous year. Also, you can check. They're not the same. Yeah. And this is 2025 and 24. Yeah. Okay, so I hope this answer your question, Paul. What else? So the Excel, is it clear? I don't know. Is this useful? Yeah, George, you want to ask something?
Sir, only for clarification, sir, if my
Uh-huh.
understanding is correct, so we can use this calculator for problems with two variables only. But if the problem involves more than two,
Calculator, you can have many variables, no
many,
problem.
okay.
Up
But
to
for
100 variables you can use.
okay, so both the solver in Excel and this calculator, they can solve many variables. I thought only for two variables for
No,
calculator.
for calculator, you can graph that up to 2. The
Graph up
graphic
to two. Okay.
graphic is only 2, okay? But the solution of number of variable you can, I think depends on your own laptop or your own computer, yeah? So if you want to do stress test, that's okay, yeah? Because that will run on your own laptop, not in my server. Anyway, so say if your laptop have GPU, I think you can reach 250 or even 300, more than the Excel. Yeah. So for small number of variable, it will run slow, but when your matrix is very big, because number of variable represent the size of the matrix, right? So then it will run rather slow. Okay. Excel, we know that this is up to 256 variables. Yeah. Yeah. The calculator actually have no real limit. Yeah. The real limit is actually your own CPU and GPU and memory. Yeah. I did not set any limit in the calculator. But roughly, yeah, for normal laptop, I think 100 is super slow already. You don't like it. Yeah. So if you have thousands of variables, don't use calculator, don't use Excel. You need to really buy a special software for optimization. Yeah. So for industrial use, and they're not cheap. Yeah, it's like $10,000 per year. But the point is, if you understand the existing method for optimization, yeah, the simplest is actually linear programming. Yeah, then you start to understand, oh, this is useful. Yeah. After this, when we discuss optimization, of prioritization, you say using MAPSA as well, and then you start to see something else. Yeah, similar, you can use LP. In Excel you can do, but not in calculator because that's integer. Okay, so up to here I will stop. So what else? Yeah, so I think as a summary, yeah, this is your takeaway. So you are no longer just designer, yeah. Now you are optimizer, isn't it? So you can listen, you can translate the problem into variables, the goals and the limits. Okay. And then you can use the calculator. Yeah. And most importantly, you need to understand, yeah, not just get the numbers, okay, but you need to understand the meaning. Yeah. What is the meaning of shadow price? Okay. You can analyze the strategy using shadow price, right? And using sensitivity analysis. Yeah. This is how you build a better city, isn't it? Okay. So yes, so optimization itself, yeah, is art, yeah, making the best of you have. Yeah. So you want to do assignment or no need assignment for this topic? Offer. If you want assignment, then I will just copy and paste this assignment one from the slide into the Moodle, and then you need to solve it individual by next week. No assignment, okay, no assignment, no problem. So so those who are interested, do it then. Okay, no assignment. Okay, good. Bonus assignment. What kind of bonus? You already got a lot of bonus. When you recite, you get bonus, right? So, okay. Uh, okay, so LP is finished. Is that okay? But if you still have question, go ahead, no problem. So I will just close this slide. Ah, today you're supposed to give your project presentation, group project presentation, isn't it? Uh, uh, so you already submitted yesterday, okay, in Moodle. So can you just briefly, maybe 5 minutes, explain what your plan is? Is that okay? Per groups, 4 groups, right? And probably we can discuss about that. Is that okay? Go. Group one, group two, group three, group four. Go. Uh, this is a little bit imbalanced because one person go out. Daniel, do you want to move to group one?
Me?
Mm-hmm.
Wait. Can I decide within before after the class?
Okay.
Yeah.
Okay. Okay.
Anyway, yeah.
Okay. Go. Can you present the one that you submitted yesterday in Moodle anyway? So yeah, Thomas. Good.
Okay, so we are group one. So one of our group mates actually has
Yeah. Left.
left. So we actually prepared two topics, and the first part of this will be presented by Lester.
Mm-hmm. Go.
Lester?
Where is Lester?
Do you see our screen already,
Yeah,
bro?
yes.
Okay. So I'll begin our presentation. So our first topic would be about the transportation network impacts of TOD or transit-oriented development in Philippine urban corridor. To be specific, we chose the site in Vertis North, Quezon City. So what is TOD? TOD is an urban planning approach that concentrates compact mixed-use development around high-capacity public transport, which prioritizes walking, cycling, and transit over private vehicles. So our base scenario is the current conditions in Vertis North, Quezon City without the proposed TOD. So this is just the land use development within Vertis North. So there are a lot of offices, malls, and then gardens, and then a residential community. So the current land use of Vertis North is a medium density, mixed use, and high commercial activity place. And then in terms of transport network, the nearest public transport is the MRT 3 North Avenue Station along EDSA. So this is EDSA, the left side of the Vertis North. And then here also located are the buses, jeepneys, private vehicles, and then within the Vertis North, there's minimal mode of transportation. It's just highly reliance on private vehicles. And then there is a low transit ridership. And in terms of the transportation network impact, there's a peak congestion along EDSA and on the internal streets of uh, that surrounds the Vertis North along Agham Road, the North Avenue. And then in terms of accessibility, it is not that accessible for pedestrians.
Oh, wait. There is someone said cannot see your slide, but I can see. Is that everyone can see the slide or?
No, sir. We cannot see the slide, sir.
I think you're the one only seeing what I'm sharing, Prof.
Eh?
The class is in focus mode, I think, to you, so we can change that so we can see the presentation.
Can you? We are in a conference meeting. What can I do to change that? Conference sharing. You cannot see their I don't know what setting. Why cannot see? I cannot understand the setting. Share screen. You are allowed to share screen. And then what should we do? Maybe I should share your screen. Okay. No. No. Oh, maybe like this. I will put you as host. Who actually share this? Okay, I will put you as co-host. And Thomas, isn't it? Okay. Can you share again?
Is my screen already visible?
Is
Yes.
it visible?
Okay.
Okay, good. Just because of that. Okay, cool.
So do I need to repeat, sir?
No, no,
Okay, then
just
let's continue. Okay. So I'm discussing the current base scenario in Vertis North. So here are the current land use and the existing road network and the observations within Vertis North specific to the existing transport network, the public transport. The nearest is in MRT3 North Avenue Station. And then in terms of the impact of transportation network, there's a peak congestion along EDSA as we experience going to the north. And then for the alternative scenario, so we are considering three TOD-based alternative scenarios for Vertis North. So the first is a partial TOD or moderate intervention. This will be implemented within the 400 to 500 meter radius of the MRT North Avenue station. And then the second is a full TOD with transport integration. This will be implemented on a larger radius, considering an 800-meter radius, which features high-density mixed-use development. And then we will implement parking protocols as well as fully coordinated feeder and trunk services going in and out of Vertis North. And then the third scenario would be the full TOD plus travel demand management. So this will include policies on parking pricing, and then there will be peak hour incentives, and then there will be also options for work from home or alternate schedules. So for the strategic structure, so we are considering actually three strategic plus the economic evaluation. So first, we will be implementing the ideal flow network. Our goal for the ideal flow network is to represent the transportation network and flows from different TOD scenarios. The one that I have discussed earlier, the three scenarios, to analyze the accessibility, congestion, and overall efficiency of each scenario. And then for the second, we will be applying the game theory, which captures the interactions among key factors like the local government in terms of policy, and then commuters, the developers who will construct the additional facilities, either residential, commercial, or transport system, and most especially the transport operators, which includes either private companies or the public. And then the third strategic structure would be the decision theory. This will support planning authorities in selecting the most effective TOD interventions under different uncertainties. And lastly, we want to evaluate the economic perspective on cost and benefit analysis, which includes travel time savings, congestion reduction, and land value gains, to identify which among the three scenarios is the most viable scenario for TOD in Vertis North. So overall, this study demonstrates how well integrated TOD strategies can reshape urban mobility to reduce car dependence and create a more efficient and inclusive transportation network in Vertis North, Quezon City. So
okay.
that's all for the first topic. And may I call on Sir Thomas for the second topic?
Okay, so since Lester has already explained the strategic structures which can also be applied to this same topic, so for our topic 2, we have chosen bicycle as an alternative mode of transport. So it is we thought of situating it within the Diliman, Quezon City, wherein it's near the Quezon City Hall. So our base scenario is how these facilities or the infrastructures are currently. So we can see in the left photo the how bikes are being transported from one lane to the other side of the Commonwealth Avenue, and as well as the concrete bollards or concrete planter box along the Commonwealth Avenue. So for our alternative scenario, we want to see and encourage end users to utilize bicycle as as an alternative mode of transportation. So I also saw recently a post from the OTR encouraging people to comment or to share their thoughts on this particular topic. So it's um, very current or very relevant right now. So I think that's it for our conclusion. So of course, progress is when public transport becomes the preferred choice for for those who can afford luxury.
Okay, so
Thank you.
I'm thinking like this, yeah. So number one, can you think about optimization? Okay, say you just learn LP, right? So can you apply LP in your linear programming in your projects?
Probably, sir.
Okay, so you need to identify the variables, okay, and then the objective and the constraint. Yeah. So so you choose among these two, okay, or maybe if you don't like this is too big, so you can make it smaller. Okay, and then the same topic, okay, you can start to optimize. Okay, number one. Second, later we will discuss about prioritization, okay, about the power and strategy and game theory and so on. Okay, so the IFN is not about the network. We have two type of IFN in this class. Yeah, 255, 252, plan 252 is about the IFN for network. Yeah, in 258, the IFN is only for prioritization and power dynamics. Yeah, so a little bit different. So think about it. Who are the shareholder? Okay, and what is the structure of power? Okay, and among all your alternative, how are you going to optimize? Number two, how are you going to prioritize? Okay, and of course, the last one is the one with the economic and financial. Yeah. So with this guide, I hope you can select better project that you want to do within this semester. Is that okay?
Okay, sir.
Mm. Okay, so I don't choose for you, you choose by yourself. But at the same time, okay, I'm expecting there is something like optimization there. Yeah, there is something like decision making there. Huh? And then there is something like the power play between the shareholder. Yeah. So these things you need to model. Okay. Okay. And how are we going to make things? What strategy to make it better? Yeah. So that the system, the whole system, will be better. Okay. So I don't like just regular transport project. You know, oh, I'm having this and that. It is just normal. I want you to create something innovative that change the world, not just the usual one. Yeah. So ordinary people are so many. You're supposed to become extraordinary. Can you do that? Huh? Because if you are just ordinary, yeah, your project is ordinary, ah, you cannot win over the AI, isn't it? So so can you think, yeah, something that extraordinary, that create a system rather than just it's a transport project selecting alternative. This is just ordinary. Okay. So search on certain more innovative than this. Can you? Okay. Okay. So group two. Huh? Can you present? Go ahead.
Is it okay now, sir?
Hmm.
Hello?
Can everyone see? I can see, but how about the others? Yes. Good. Go.
Okay. Okay, good evening, everyone. So we are Group 2, and our group name is Transit Trio. So we are composed of me, myself, George, Apple, and Corinne. So for our tentative topics, we propose three relevant, timely, and long-standing transportation issues here in Metro Manila. First is the illegal on-street parking. The second one is the PUV commuting experiences, and the last one is the traffic congestion here in Metro Manila. So I will not say anymore our group objectives, but our objective is to help improve the transportation system in the Philippines, particularly here in Metro Manila. So for our first topic, this is the illegal on-street parking. So in how it relates to the imbalance between parking supply and parking demand in residential areas, specifically along Commonwealth Avenue in Quezon City. So there is a parking supply and demand topic in this problem. So this photo on the right side shows the study area. So this is a subdivision residential community, which includes a total of 12 buildings or 12 medium-rise condominium buildings with 960 dwelling units. So however, this subdivision provides only 210 on-site parking slots. So this means that the ratio between parking slots and dwelling units is only 210 is to 960, or roughly one parking slot for every 5 households. So from a transportation planning perspective, this indicates a structural imbalance between parking supply and the demand or parking demand, which creates conditions such as this illegal on-street parking. So for our base scenario, we describe the existing condition as an unregulated and informal parking environment. So as shown in these photos, which I just took a few days ago, in this area, there is a high dependence on on-street parking, mainly because of the limited availability of on-site parking within the subdivision. So since many households own vehicles, but no parking spaces within the subdivision, they rely on nearby streets for illegal parking. So also in this base scenario, the enforcement also is weak, and the curbside rules are unclear or inconsistent. So as you can see in these photos, there are no signages that parking is not allowed. There's also no enforcers checking the area for illegal parking. So this allows parking to persist and become normalized. So this kind of urban problem does not only exist in this area, actually throughout Metro Manila and other cities in the Philippines. However, to simplify our study, this area serves as our model area for the project. So for our alternative scenario, Mm, the first one, the first one is focuses on addressing the supply side by utilizing vacant and private lots as supplementary parking supply. So as shown in this map, the yellow nodes represent the existing 210 on-site parking slots within the subdivision. The pink nodes indicate the nearby parking facilities that some residents are currently renting. Then the red nodes highlight the vacant or underutilized private lots that may be converted into temporary parking spaces. So the main strength of this scenario is that it directly addresses the root cause of illegal parking, which is the lack of parking within the subdivision or the demand. The demand exceeds the supply. So this scenario also has several limitations, including land availability and cost constraints, safety and security concerns, and community acceptance. So the second alternative scenario, we focus on enforcement-based approach. So under this scenario, clear no parking zones are established, particularly along sidewalks, intersections. Enforcement is strengthened through increased ticketing and towing, supported by the barangay level monitoring to ensure consistent implementation. So the main strength of this approach is the ability to generate a quick behavioral response. So once enforcement becomes visible, or the driver can see some enforcers in the area, motorists are more likely to avoid illegal parking in this area. So however, this scenario also has limitations. First, it is unsustainable without continuous enforcement. So if illegal parking tends to return once monitoring becomes weak or there's no enforcers on site. So second, it does not address the underlying parking demand since it does not provide additional parking supply. So for our third alternative scenario, it focuses on street space reallocation and parking demand management. So under this scenario, the curbside space is regulated and assigned to specific uses such as loading and unloading, short-term parking, or pedestrian protection zones. So parking may also be like time limited or paid parking. So if it's time limited or paid parking, it will discourage long-term on-street parking or illegal parking. So as a result, vehicles are less likely to occupy this area. So the main strength of this approach is that it balances mobility, accessibility, and safety. So however, this scenario has also some limitations as it requires strong coordination among local government units, clear regulations, and gradual rollout to allow users to adjust to new parking rules and pricing schemes. So for our strategic structure. So it's related to this regulatory. I will not specifically discuss all of this. So I think maybe we can proceed to the next topic, which is the PUB commuting experience, which will be discussed by Apple.
I guess, good evening, sir. So for next slide, please. Next slide. Okay. So for topic number 2, we would like to focus on the assessment of college student level factors influenced by PUV commuting experiences and their relationship with academic engagement. So this research topic aims to examine how PUV commuting experiences influence the academic engagement of college students in dimensions such as cognitive, behavioral, and emotional. So PUVs remain the primary transport mode for students in Metro Manila, particularly those from the peri-urban areas such as Rizal province. So daily exposure to long travel times, congestion, and multiple transfer can shape students' behavioral engagement, emotional engagement, of course. Lastly, the cognitive engagement. So this research aims to understand how commuting conditions relate to these three dimensions of academic engagement and to explore possible planning and policy responses. Next slide. Under current conditions, higher education institutions are highly centralized in Metro Manila, requiring many students to travel long distances each day. So students regularly face traffic congestion, crowding, waiting time, uncertainty, and multiple transfers. These commuting realities can influence how students manage their schedules, arrive to class, and allocate time for academic responsibilities. Next slide, please. One possibility is that one possibility that we've seen is that the increase in travel time, congestion, and commuting stress are associated with the gradual reductions in academic engagement. Another possibility is that students facing heavier commuting burden may experience larger declines in engagement compared to those with less demanding commutes, even within the same institution. So this relationship are aimed to be tested for this study. Next. So the first alternative scenario focuses on improving the transport system for TUV commuters, especially targeted to students. Possible measures may include improving service reliability, reducing waiting time and transfers, and prioritizing TUV movement in congested corridors and enhancing safety and comfort. So next. The second scenario focuses on the education policy responses. Higher education institutions may adopt student-centered scheduling approaches, including flexible class hours, hybrid or asynchronous learning options, and reasonable consideration for transport-related delays. So this measure may acknowledge commuting realities while helping students maintain academic engagement. Next. For the third scenario, it proposes coordinated planning between transport agencies and higher education institutions using commuting data and spatial analysis. Planners can identify high-burden student corridors, align transport improvements, and with university locations and support more student-oriented mobility policies. So in conclusion, this study highlights the importance of understanding how commuting conditions shape student academic engagement through, I think that would be all. I will not be within this plan. So I'll be passing the floor to Ms. Corinne to discuss Metro Manila traffic.
Uh, for our third topic, we will be focusing on the factors influencing Metro Manila traffic. Next slide, please. So for our base scenario, we research regarding the factors regarding the traffic in Metro Manila. So based on TomTom's traffic index report, so TomTom is a Dutch developer for maps and navigation. So based on their 2025 rankings, Metro Manila ranked at 40th place as the worst traffic um, in the world, competing with their 2024 rankings by Metro Manila placing at the 15th place. So it shows that the 2025 traffic situation somewhat improved, as we can see here in the metrics shown in the photo. So for morning rush hour, the average congestion level in Metro Manila is at 69.9%, and the acceptable rate of traffic congestion level based on studies is at 15 to 30%, with acceptable up to 50% increase in fast growing cities. So for evening rush hour, it shows that the average congestion level in Metro Manila is at 107%. So that shows that the congestion level in Metro Manila is significantly high. Since based on studies, the acceptable traffic congestion rate is at 0% to 10%. Next slide, please. So for our base scenario, this one is based on direct observation as we travel in Metro Manila by commute or private vehicles regularly. So for our first observation, the congestion in Metro Manila is a long-term problem with various solutions created over the years, but the congestion has not significantly improved. Next is Metro Manila is not pedestrian friendly, so there are no proper sidewalks, bike lanes, and there are emerging expressways such as NAIA X, Skyways, but the roads are still congested. And also, to add in this scenario, we also have dated trains, which is significantly slower if we would compare it to other countries. Next slide, please. So for the resulting impacts of this topic, it shows that it lowers the productivity, reduces the quality of life of people, and fuel waste. Next is the increase in transport fares and higher demand for a number of vehicles due to limited public transportation options. And lastly, increased car ownership resulting to additional volume to congestion. So, existing alternative scenarios that we have right now is the use of public transportation such as trains, bus, jeepneys, and e-tricycles. And also, encouraging companies to implement the hybrid or work from home setup. Next slide, please. So, for our strategic structure, um, addressing Metro Manila traffic focuses on strengthening the mass public transportation while reducing the reliance on public vehicles. And this also includes improving the efficiency and accessibility of using the use of trains, buses, jeepneys, and emerging modes of transportation. Also, corporations and offices are encouraged to do hybrid work setup or complete work from home setup to manage peak travel demand. Overall, the approach is incremental and coordinated, addressing congestion through transport improvement and demanding management rather than road expansion alone. So that wraps up our topic proposal, sir. Thank you.
So you choose again, yeah, the same comment. You choose something that you can optimize, okay, and you choose something that you can prioritize, and check the shareholder power dynamics between them. So select certain uh, project that you can actually do within the time limit that you have. Uh, For example, I give you example. Can you show me, for example, one of the slide? Say the first one, parking lot, right? So in this case, you're talking about demand and supply. Okay, you already showed the demand and supply, but something there that you did not show. Okay, so this one is about demand and supply. You already have. Now, there's assumption then, right? That
Yes, sir. Yes, sir. That I
acceptable
got.
walking distance, for
Yes.
example. Yeah. So, question: how to force them? Okay, this is planning, right? So you need to have how to force them. Force in the quote, yeah, that using your plan, they will behave as you design. That is urban planning. If you just propose without strategy, okay, just blah blah blah, okay, that is not useful at all, isn't it? So with strategy, you need to think how to force them to do what you want. That exactly planning is. How to control the behavior of people. Next slide. The next slide. Okay, so this one, you are talking about unsustainable without continuous enforcement. How to force the enforcer to do continuous enforcement. What motivates them? You need to think of strategy so that the system that you design will behave exactly what you design. Can you see? Okay. Not just proposing something and then let others do whatever they want. That is not planning. You got it? Planning must be systematic enough in order to say, this is what they need to do, and this is you guard the system in order to make they will behave like what you design. Okay, using Nash equilibrium, using design mechanism, you can do that. You can create a system in order to force them to do what you want. Okay, it's not just proposing something. That is not enough. You got it. You got the idea of this course, yeah? If you just do this is just the usual, right? There is no innovation in here. Okay. But you try to think how to force them. Next one. Next slide. You're talking about the limitation, require coordination, right? So how to force them to coordinate? As long as they remember this, everyone have self-interest, isn't it? Okay. If you can provide so that everyone win based on their self-interest, if you can create the self loop, check and balance, they will be forced to do what you want. That's exactly what planning is. Okay, not just proposing and then say that this is the limitation. That's not enough. You need to tell how to force them to coordinate. Is it clear or not? The same thing with the next alternative solution, yeah. The next topic and so on, yeah. So you need to think strategy in order to remove all this limitation that you mentioned. You got the idea? How to optimize this? Just telling this as limitation, very easy. Everyone can say that. There is no need to planner to do that, isn't it? You are planner, so you need to think deeper than that, not just in the surveys. Is it clear?
Yes, sir.
Oh, with that, now you can start to see how deep it is. No need to be so wide, okay? So very big area, so wide topic. Just small, but you can control. That's enough. Yeah, and go deeper. Or the plan that have some certain problem, you have plan B, you have plan C. in order to back up this plan. If this fail, what will happen? If that fail, what will happen? That is what is called planning, isn't it? Not just proposing something and then, oh, after that I have a limitation on that. That is not planning. Correct? Yeah. Everyone can propose, With the AI, everyone can do this kind of proposal. But your case, you go deeper, 2, 3 level deeper. Then you will see, oh, I create something extraordinary based on this. I hope this click your thinking. Okay? How to force them to do what I want. What kind of system I should create. How to motivate them. That is what control and planning is. Okay? I hope this is clear, yeah? This is recorded. I'll put it publicly in YouTube. Okay? The one that you just proposed is very good. Okay? I'm not telling this is bad. This is very good, excellent proposal. But we need to go deeper than this. Because all this proposal AI can do. You are human. You go beyond the AI, isn't it? Okay? Okay. The next group. Okay. Yeah, thank you. Go.
Hello.
Yes,
Is my screen visible?
yes. Yes. How about the others? Can see?
Yes, sir.
Okay, good.
Okay. Okay, so uh I am with Jazz and Diane. I'm Andro, so
This
so
is nice.
and our first meeting was all about mapping our interests and generating a rough topic, our rough destination for this project. And we noticed that we are interested in the same thing, that is space. So we called ourselves spatialists.
Okay,
So so Jazz is interested in critical and cultural geography,
that's nice.
and I think that was aligned with my interest on design philosophy, on how to deal with the power structures that critical or cultural geography exposes. And then Diane was interested in travel behavior, aligned with psychology, and lastly, we just align in social spatial analysis. So, uh, the issue regarding this general area that is slowly getting traction is the the rise of the private enclaves, the gated communities, the private residential subdivisions.
Mhm.
So, uh, it is often that these subdivisions, these gated communities, uh, uh, while they think they are compartmentalized, that they can't affect their surroundings, but uh, they affect the network surrounding them, and that affects directly the travel behavior of the surroundings. So that's where we went, and so Jess will be discussing the specifics of the topic,
Mhm.
and later Diane. Thank you.
Hello, good evening, everyone. I hope my audio is clear. As Andrew mentioned earlier about the power structure, we okay. Sorry, sir. I cannot start my video because I am in a public space. I hope that's okay. Um, For our first topic, we found common grounds with our interest in the power structure, spatial analysis, and design philosophy in the gated community, the structure of subdivisions, especially the subdivisions across the national capital region and all the peripheral municipalities near the center. So for our first topic, we want to analyze and understand how the subdivisions, the gated communities, influence the mobility and transportation networks around it. So subdivisions, uh, as Andrew mentioned again, they think they are compartmentalized. They are designed as closed systems, but they influence the surrounding network by limiting the uh, roads that connect places. For example, in the south of NCR, specifically in Parañaque, where vast expanse of subdivisions are located, and the transportation networks, the primary transportation networks are very sparse. The roads inside those subdivisions could have offered some sort of shortcut or pass-through ways that could have solve the transportation congestion issues in the south. But since they are operating very restrictively, they impose these kinds of restrictions that kind of limits the mobility of the people and somehow concentrate the accessibility of the areas to the residents of the gated communities. So our base case scenario for the gated communities, uh, those subdivisions that impose absolute restrictions. You cannot pass through their gates. You cannot um, use their roads as shortcut or pass through ways if you don't have certain stickers or you're not a resident of that area. So the base case scenario is absolute restriction, and the second scenario you would like to look into is if those subdivisions lifted their restrictions. And the third one is the optimized kind of restriction. So you would like to understand or kind of simulate how the optimized restrictions in those subdivisions could affect the surrounding primary roads of those gated communities. Our second topic is almost similar to the first topic. Is also about gated communities and the issue of access specifically of the non-residents of such gated places. So the second one is public access to parks and open spaces, and accessibility comparison between residents of gated communities and the general public. So we tried to map, well, at least from the area where I live in Parañaque, I tried to map the open spaces located in Parañaque, and most of them are inside gated communities. So it raises the question, uh, who can access those coveted open spaces? So it's also an issue of power and inequality. Um, Same with the transportation network. We also want to understand access in terms of the open spaces. So the base case scenario is, again, those open spaces are confined inside gated community. So base case scenario is, well, general public cannot access the open spaces inside the subdivisions. The second scenario is, um, if those gated communities allowed access of those public spaces even to non-residents. And the third one, optimized restriction, where the right kind of rights afforded to being a resident of a gated community is still afforded to you as the resident, and also granting access to the general public. So our proposed sites are located scattered across National Capital Region and also in the outskirts. So Parañaque City, as I've mentioned, we have a lot of gated communities, and they really offered shortcuts, but you cannot really use those roads and unless you have some kind of sticker you have to purchase every year. Or yeah, here's the map. Even though they are located in different parts of NCR, the morphology of those subdivisions are almost the same. So the subdivisions occupy a lot of space in that certain city, and the transportation networks around them are very poorly designed. And so the subdivisions could have offered some sort of shortcut for them. The first one is in Tumana. So Tumana to Marikina. So uh, the second one is in Parañaque, as I've mentioned. More prominently, the BF Home subdivisions and the multinational village near the airport. And the last one is in Dasmariñas City. For the variables we would like to research on this topic, Andrew. Uh, thank
I
you.
will further expound on the variables, but I'd like to share more first in DASMA. So in DASMA, I did also study, and there are a lot of residential subdivisions closed uh, to the public, but they were forced by the traffic management unit to open up, ironically, because the surrounding roads have traffic congestions, and they are finding ways to alleviate that. So that's an interesting site too. So
Yeah.
for for the variables, as said, we are going to look at the restrictions like toll fees, uh, conditional pass-throughs like when you're a resident, or also the when you have a sticker, uh, and we will be gathering that using secondary data because I collected before for DASMA. And for the other sites, I think we are familiar with the place, so we can do our primary encoding. For the public and private parks location, we'll just use OpenStreetMaps and primary encoding. This is for topic 2 because that's the interest. And then for both topics, we're going to look at the transportation network. This is a placeholder because we haven't tackled yet the deep end of IFN, but we are hoping to learn more and measure about transportation network.
Okay.
For for road network spatial accessibility, this was this is one of my research too, so I will be trying to integrate that in this project and explore. So the purpose of these variables was also to explore the effects of of different scenarios to these different variables. And we'll also look at the population catchment, maybe using isochrones and the annual average daily traffic from DPWH, which is public data.
Okay.
Okay.
Good. So, can we go beyond that?
Sir, we have one last
Okay.
topic.
Okay.
We'll just quickly. Hello, Diane. So you may present
Okay.
now.
Cool.
So for the third topic, which is the distribution of malls versus open space and its effect on population coverage. So this explores how different land use conversions, specifically malls versus parks or and green open spaces, how it affects yung population coverage and secondary that we want to explore is its effect on trip demand in Quezon City. So for the scenarios, we have the first one, the base scenario. So the existing land use is retained and the population coverage is uneven, and we have limited green spaces, and the trip demand is already high. So um for the scenario two, which is the vacant lands to or gray areas to parks and open spaces, um we can look into improvement in access to green areas, and especially for nearby residential communities, and the effect on its trip demand and how it will be localized, shorter, or how it will encourage non-motorized or active mobility. And for the third is vacant lands to malls. So of course it will increase the access to goods and services, but also it will have corresponding trip attractions. So this may result to higher trip volumes and relatively longer travel distance, and will um, then increase congestion, and lalo na ay particularly in peak hours. And then for the optimized scenario, wherein we aim to meet the WHO or World Health Organization's recommendation of 9 meters squared per capita of green open space, and how the green open space will be distributed within the walking distance or residential areas. Ayun po. So that's for the third. Basically for the optimized, we
Yeah.
want to meet the we want to be closer to the WHO's recommendation of 9 meters squared per capita of green open space,
Okay.
and basically explore the trip demands that it will cause.
Yeah. So this is very similar to the LP, right? A while ago. So the mixed land use, right? So this is easy to optimize, but can we go beyond this? Meaning, one is optimization, right? The question is, again, yeah, in planning, you need to tell me how are we going to plan and make sure that plan will be successful, that people will behave like what you want. Okay, so you need to think of strategy. And so beyond that study, so topic 1, 2, 3 is the same. Yeah. So you have proposal. Okay. Okay. The third one is very obvious that this is going to be optimized. Actually, the first and second is can be also, but a little bit more difficult, right? But at the same time, what I want is how are you going to strategize so that your plan will be successful? Okay, that people will behave according to your plan. Okay, what kind of rule? For example, the first topic, the gated community, yeah? Or the second topic. Can you come back above? Yeah. So this is obvious that the optimized restriction probably the best, right? But how to make the gated community willing to get this optimized solution? Yeah? It's not just proposal, not just getting the result of computation. Because even if you have this result of computation, will they willing to accept that? No, right? Then you start to think about each of this community or the public. They have their own interests, isn't it? Then how are you going to combine all of this so that your plan will be successful? Can you make sure that? Okay.
Uh, Sir,
Yes.
will using game theory help
Yes.
us? Okay. I'm looking forward to learn. Okay.
Okay. Game theory, power dynamic will help you a lot. Yeah. So you can start to search. Okay. And you can start to search mechanism design, for example. Yeah. So then you start to see, hey, apparently I can control people. Okay, how they behave as a community. Yeah. Okay, as long as I give this something and I penalize this something, so this is very important. You know? Because everyone can propose, everyone can do this. Okay, but after that, so what? Just because become a paper published, nothing will happen. No, nothing change, right? Because you don't make sure your plan will be successful. So this is not what I want. I want go beyond this. Can you? Yeah, I know it's a little bit hard, but once you learn this, okay, suddenly you will have empower yourself, isn't it? Hey, I can do this. Okay. So I hope this encourage you to study further. Okay. Okay. Thank you. So last group, yeah, but not the least, yeah. So group 4.
Okay, sir, let me share my screen.
Okay.
Okay,
Hello.
so
Hmm. Okay.
can you see my screen now, sir?
I can see, but how about the others?
So my group mate Daniel will first present our first topic, followed by Roger and me. So, Sir Daniel.
Oh.
Hi. Okay. So good evening, everyone. So one of our options is currently entitled strategic hub locations for centralized EV or electric vehicle TNVS or transport. Wait, let me uh, Transportation Network Vehicle Service or TNVS operations in Metro Manila. So the context is recently there is a new player in the TNVS sector in Metro Manila, which is the Green GSM, which is a Vietnamese corporation who has a fleet of, if I'm not mistaken, around 5,000 electric vehicle taxis. So it's quite a game changer because the way it operates at TNVS is quite different from Grab or say Joyride, wherein the latter is highly decentralized, where drivers can just get a franchise and they can become service providers of Grab or Joyride. However, this one hosts their own electric vehicle fleet, and therefore that also gives us a set of new assumptions and perhaps also a new set of problems. So, uh, for context, that would mean that they would need a large hub. Currently, there is a central hub in Las Piñas and in Caloocan, and each vehicle cannot go more than 14 kilometers from their respective origin per trip. So with that, we thought of how do we optimize the locations of the hubs uh, determined by different goals such as coverage of people, maximizing capture of demand, and of course, maximizing also the potential profit or the potential income of the corporation. So quite the scale is really the on how to govern or how to govern or to plan the transportation scheme of that corporation. So research questions we currently identified include how do we optimize and plan hubs to maximize demand coverage and minimize distance cost? And that may even be something that we can modify later on. How do we decide, prioritize given significant cost of setting up a hub? So that includes acquiring land, acquiring local permits, as well as trying uh, to procure relevant equipment like charging stations, etc. What are the constraints of the current location hub planning of the case study EVP and VSO? What are the constraints of the baseline uh, with respect to capturing demand, with respect to maximizing income? So next slide, please. So actually, there is an originally there is is at least six scenarios, but we combine them. So it is these three. So again, assumptions are a centralized fleet meant electric vehicles are dependent on hubs. So in contrast to franchisee model PNVS, which can roam everywhere in the metro. So a given electric vehicle cannot go too far from a given hub. So vehicles have a traveling limit of 14 kilometers from origin of a booked trip of our customer. Then provisionally the study site is Metro Manila. So some of the notable factors include the fleet hubs, which includes the location as well as the number, as well as the capacity of each hub. So how many electric vehicles can they host at a given time? Then location factors include place of residence or of people, as well as destinations such as schools or work. Then definitely there's also the question of land availability. So for the first scenario, we have the baseline, which is the current one, where the current fleet hub locations are in Caloocan, which is a northern city, and Las Peñas, a southern city. So we currently presume that it's because that's where they can actually buy relatively affordable land. So of course, the nearer you are to the center, the more expensive. And of course, there's only two versus a greater number because uh a bigger hub might be helpful. Then, for the first scenario is what if we instead introduce smaller dispersed hubs, maybe one per city or maybe one per sub-region. So priority is on equity, can be based on residents or trying to have greater coverage of residences. So it can be correlated with population density, so trying to cover as much residents, which is also correlated with the origin of a given AM or morning peak OD matrix. However, that would also mean the hub size would be smaller, but the number of hubs across the region is greater. For the third scenario, we have what if we just add fewer sub-regional hubs in major malls or CBD. So demand is presumed to be concentrated near malls. Malls and CBDs are easier to set up given the private sector's established presence. So that is perhaps a motivating factor for them to actually invite Green GSM to set up hubs in their respective malls. That can be planned or correlated with higher zonal values, or it's not yet here, but it can also be higher daytime population as mentioned in MUCEP or other government baseline data. Destinations in ANPIC OD matrices, that would also mean the hub size can be bigger, however, it's a bit less than the second scenario. So that's our first option. I give the floor to.
Okay. Roger?
So, sir, our another proposed topic is the EDSA decongestion schemes. So we have all experienced this. So currently, many people rely on cars to travel around Metro Manila. So this is while improvement of the public transport systems is pending. So this will just be quick. So next slide, please. So our proposed solutions. So first alternative is the to impose congestion fees. So we will look into the feasibility of charging drivers for a fee to use EDSA during peak hours. Second alternative is the implementation of ITS. So this can help drivers to avoid congested areas and choose alternative routes. Third is the staggered work scheduling. So this will involve the adjustment of the start and end times of work shifts to spread out the flow of traffic for a longer period of time. So our considerations in our the analysis that we'll be doing will include we have read the IFN power dynamics in the group internal report that you have shared in Moodle. So it was used in the whale shark interaction project. by uh by the previous group in a group in your previous class. So we'll look into the relationships and interactions of stakeholders. So involved in the implementation of policies. So the structure of power of the government and private sectors. So for the government, the LGUs and national government agencies like the OTR, LTFRB, the MMDA, and for the ITS implementation, this will involve the ICT and the National Privacy Commission. For the congestion pricing, I think in the scheduling of staggered work, this will include the company owners and also the the NGA secretaries. So other analysis that will be employed include economic evaluation and other analytical tools that may be deemed appropriate as discussed later on by Prof. Cardi. That's all for the second proposed topic. I'll turn you over to Paul for the third topic.
Thank you so much. This would be the last proposed topic for this class. So, urban sprawling in Metro Manila, optimizing origin destination distribution. So, to keep it direct, we all know what urban sprawl is. The space in National Capital Region or Metro Manila is so dense, and the growing population demand only provides one option for our population. It's to sprawl out on the adjacent regions of GCR, Cavite, Laguna, Rizal, and Bulacan, which is urban sprawl. So this idea came from a bold claim. Basically, we wanted to prove that cars are not the main reason for traffic congestion in our country, but rather the urban fabric itself. The locations of thrift generation zones, which are our residential zones, versus the locations of the trip attraction zones, the industrial, commercial, and business hubs in Metro Manila. So our alternatives for this would be straightforward as well. So our base scenario would be the existing urban fabric that we have, on which majority of our commercial, business, and economic districts are in Metro Manila, while the trip generation zones comes from outside of Metro Manila, which induces more travel demand and leads to congestion. While the alternative scenario number two, what if we transfer the trip generation zones inside the Metro Manila itself by having in-city high-density housing? Would it reduce travel demand? Would it reduce congestions on our roads? If yes, by how much? So we wanted to test this one in our simulations as well. And alternative number three is the exact same urban fabric that we have now, but rather than having a road-centric transport network, what if we have suburban rail service like what we have in Tokyo, on which the Tokyo Central is also connected to its adjacent prefectures via rail? Would it also reduce the demand and congestion on our roads? If yes, by how much? Is it a better solution than having in-city high density housing? And I think another alternative that can be applied here is the same with the previous topic, the staggered work scheduling, or previously mentioned the flexible work arrangement. Would it reduce the demand as well? So in summary, rather than proposing a transport solution or focusing on the transport system itself, this topic will play on the urban fabric or alter the urban fabric itself on which uh, it would manipulate where the trip would originate and where is the locations of the trip attraction zones in order to optimize and find the most ideal urban layout for NCR. I think that would be all, sir.
So the three proposals are very good. Okay, but the first one is excellent. The second one is just the usual alternative that people always suggesting. The third one is a little bit innovative in terms of using land use, right, rather than just transport. Okay, but I want to have certain uh, make sure that your plan will be successful. That's the goal, right? So in that case, probably the first topic will be easier for you to do. What do you think? Hmm? Because the three of them are very diverse now compared to the previous group with this within the same scope. But in your group, it seems very diverse. So, for example, if you push to the second topic, okay, this is will be very broad, and then if I ask you how to make sure that this will happen, I think it's also very difficult because the alternative are very broad also. Yeah. The third one is a bit narrow, but after you get all these alternative, so what? How are you going to implement this? There is no plan yet. Right? But the first topic that you discussed, it seems a little bit more detailed, and I think this is clearer, what to do. What do you think about that?
Yeah, sir. Even among the group, we actually calculated the top three, and actually, the first one is also the one who garnered more consensus between us. So yeah, I mean, me personally, I'm imagining it we can apply, or at least my background in GIS can be applied here for perhaps site selection and other data set manipulation, then
Right.
definitely added with the new learnings we could put. And it's quite an interesting thing too, since it's a relatively new topic that can be discussed
Exactly.
for
Yeah.
methodology.
Yes. So the topic is relatively new, and there are many things we are not sure about this. Yeah. So I think this will be very nice to push. Yeah. Okay. Yes, Paul.
Actually, we are just like what Daniel said. The first topic was our first that came out first in our votings as well. I
Okay.
just wanted to ask if game theory and decision theory can be applied on the range aspect of electric vehicles. Because the main challenge here is that, yes, electric vehicles are much more efficient, they are much more cleaner form of transportation, but unlike internal combustion engine cars, they cannot run on forever. They have this so-called range anxiety.
Right.
I would like to explore if game theory and decision theory would be
Of course,
helpful in locating the ideal
it
hubs.
it is possible to uh, move into that direction. Yeah. But I think you already defined your scope narrow enough for the optimization, which I think is already very big. If you want to go deeper on that alone, this is already very big, no? So try to do prioritization after that. For example, yeah, so you have what is the number of optimized hubs, and then what is the size? Okay, so within that 14-kilometer distance that you want, right? So, and there are many decision variables that you need to input already there that you need to optimize. Okay, and you can make it several layers on decision if you want that, and then after that you need to prioritize which one first, and then you have uh, limited budget, right? I don't think you have unlimited budget.
Yes, definitely. And it's also nice to see because there are actors like the private sector, maybe the decentralized one, maybe the city governments can also be actors here. particularly in terms of land availability. So that
Yeah,
I'm not so sure yet how
yeah.
exactly politics or power play can be
The
applied to
power
so
not
far.
necessarily politics. So within the organization, within that particular company or between companies, competition, for example, that can be also part of that power play. Yeah. So not necessarily with always with the politician.
Okay, so
Okay. So I think that scope alone, if you go deeper, will be big enough for this semester. Yeah. Okay. Yeah. So thank you very much for today. So next meeting we discuss about prioritization. Okay, you can start to read and we discuss also about MCDM, yeah, multi-criteria decision making. Okay. Okay. So with that, so thank you very much. So sorry, the discussion is longer than the usual. So see you next.
Thank you, sir.
Yes.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.